Hi everyone, so we are live now, and this is going to be our lecture number 11. So I believe my voice and everything is okay, and we are actively working on signals. Right, so this is going to be lecture number 11, and we are discussing discrete time signals. Right, discrete time signals. So in the last session, we have discussed about time scaling as well as time shifting. Right, so in case of time scaling, we have to be a little bit careful when we go for time scaling in case of discrete time signal. Okay, because since we know that we are when we discuss about discrete time sequence, we have to deal with the integer values, right? So we have to make sure that the while doing time scaling, your time should be integer only, right? So you might have seen I have discussed two things. One was decimation and one was interpolation. Okay, so in both the cases, what we are doing exactly is we are changing the length of the sequence, or you can say we are changing the sampling rate, right? So when we go for decimation process, we downsample the sampling rate. Okay, sampling rate is gonna be decreasing, and in case of you can say in case of interpolation, the sampling rate goes up, right? So these two things you have to remember. That's it. Okay. Now in this session, I'm just going to talk about fractional delays, right? So what is the meaning of fractional delay? Fractional delays, right? What is the meaning of this fractional delay? Okay. So the fractional delay is nothing but you can say it is nothing but you can say half sample delays, right? So fractional delays are sometimes required in practice, okay, and that can be implemented using interpolation and decimation. So we can introduce this fractional delay with the help of interpolation, okay, and decimation. So both the thing will be present, okay. Interpolation will be there as well as decimation. ठीक है. So hopefully आपका linear interpolation clear हो गया होगा. In the group Devans has shared the solution as well. But if you are not clear still, then I will explain, right? So fractional delay has got two things. One is interpolation, one is decimation, right? So so if we require that, suppose we have to perform both, right? Interpolation and decimation. So what will be our first choice? So interpolation has to be followed by the decimation, right? This is one of the important point. Interpolation, सबसे पहले हमें क्या करना है सर? Interpolation करना है. Interpolation, right? Never perform decimation first, right? And then we will perform the decimation. Right? Then we will perform the decimation, and then we will shift. Then shift by what? Shift by the integer. Okay, so this will be the process of fractional delay to get. Okay, so if you want to introduce fractional delay, सबसे पहले क्या करना है आपको? You have to go for interpolation. Why we go for interpolation? You know, अगर आप decimation कर दोगे तो there is a potential loss of, there is a loss of potential information, you can say, right? So to get back the same sequence, it will be very tough, right? Despite you might recover the original sequence, or you might not, है ना? दोनों cases हैं. But in case of if you go for interpolation, right? So आप interpolation करते हैं, then you might get you might go for decimation, because decimation is nothing but the inverse of the interpolation. ठीक है? So you might get, right? Fine. So this is one of the important fact that you have to remember, right? So the only sequence of operation that will yield the correct result is what? Interpolation followed by an integer shift and decimation, right? So I will show you. देखो, so fractional delay requires what? Fractional delay of x of n. Fractional delay of x of n requires what? First, it requires interpolation. ठीक है? पहला क्या है? Interpolation. And second, that you have to perform. See, I have told you here interpolation, decimation, right? This sequence you have to maintain. But suppose there is a shift also. So what you can do here is you can first perform interpolation, then you can go for the shift by the integer, by the integer, then तीसरा हो जाएगा, the third is going to be what? Third is going to be decimation. Decimation. So this order you have to maintain always. This order you have to maintain. So how does fractional delay look like? Okay. So suppose you have got x of n. देखो fractional delay का मतलब क्या होता है? I'm just going to delay it by, you know, I'm just going to shift x of n by m by n. This is the fractional delay, right? The amount of shifting is nothing but m by n. ठीक है ये. So what, how can you write now? N minus m by n, right? So this is nothing but a fractional delay, right? Earlier we used to shift it by integer value n naught, you can say, but now what we are doing here is we are shifting by the fractional delay. This is nothing but fractional value, right? M by n, the ratio of, you can say, two integers, right? Ratio of two integers, understand? Okay, so we are shifting x of n by the rational number m by n, or fractional number, right? Now since you know this n minus capital M by n, so you can write this as you can take the LCM of this, right? So आप LCM लेंगे तो n आ जाएगा, and this is small n capital N minus m, right? So this is what I wanted to say. Yes, okay, understood. So I hope this makes sense to all, right? So this is one of the important point that you have to remember, right? ठीक है. So see how I'm getting, this is the meaning of fractional delay, right? So now whenever you will get this kind of a situation, so first of all you have to perform interpolation, right? It can be zero interpolation, whatever you can go for, and then shift. Okay, so interpolation by what? Interpolation by capital N, right? Shift by capital M, and then तीसरा क्या रहेगा? Decimation by capital N. Okay, so these are the steps that you have to perform. Interpolation by capital N, shift by capital M, and then ठीक है ये, these are the steps that you have to perform, right? So you have to interpolate by capital N, then you have to delay, shift, or you can say delay. This is nothing but delay, guys. Shift or delay, you can say, right? Delay, right? Delay by capital M and then decimate by capital N, right? So we will take one example here and we will try to understand this concept, right? So suppose we have got one question, ठीक है? तो जब भी अगर तीनों ऑपरेशन कंबाइंड रहेंगे, यू कैन से दैट okay, all the operations are combined here, right? You can say decimation, interpolation, shifting. So सबसे पहले करना क्या है? This sequence you have to remember always, right? ठीक है ये. Now this is a question here, right? From the embedder only. So the question says that we have got this sequence x of n, and this is the marker point n equal to 0. उसके पहले -1, -2, okay, like this. Now you have to find the by of n, that is nothing but by of n equal to x of n minus 1 by 2, right? So what they have given here is they have asked you to find out the they have asked you to find out what? They have asked you to find out the fractional delay here, right? So this is nothing but fractional delay. So you can write this as 2n minus 1 by 2. So what they have written here is you can assume the interpolation where linear interpolation wherever is needed, right? Okay. So linear interpolation wherever is needed. Understand? So what is the first step that you have to do? First step you have to do is you have to what you can do here is you can go for interpolation, right? Interpolation by 2. Matlab you have to find x and by 2 first, right? So what is that? Okay, so between these two, between how many new samples you have to add? So new sample, number of new sample, that you have to add is nothing but 2 minus 1, which is 1 only, right? So only one you have to add means what? You can take the average of the two, right? So 2 and 4 ka average you can take, right? So 2, and then it will be nothing but, I believe, yes, ठीक है, average of that. So 2 and 6 का average आप लेते हैं, 2 and 4 का average लेंगे तो कितना आएगा? 3 आएगा. Then 4 and 6 का average लेंगे, ठीक है, I think, yeah, 4 and 6 का average लेंगे, yes, तो 5 आएगा. You can take 5 here, right? These are the new samples I am attaching. Now 6 and 8 का अगर आप average लेते हो तो क्या आएगा? Between 6 and 8 there will be 7 now. Okay, and now there is nothing, okay, left, only 8 is there, so you can take 0, and 8 plus 0 by 2, you can say the average is going to be 4. ठीक है, तो ये आ जाएगा आपका interpolation by 2, right? This is nothing but interpolation by 2. Now and you can also follow the technique which Devans has suggested, right? Since there is a interpolation by 3, so you have to add two values, okay? So you have to take the average of, okay? So what you have to do here is you have to find the step size between two, okay? Understand? So you see there, in that interval, in that gap, you have to fit two values, okay? Understood? You have to fit two values, and that must be the average, okay? So you can follow that technique also, so you will find the same answer like this, okay? So these are the new value that I have introduced, right? ये नई values हैं. This is because of interpolation. Okay, now you can shift it by what? One time, right? So please keep in mind where is n equal to 0. That is also one of the important points. So this is nothing but n equal to 0. Now you can shift it. So shifting matlab you have to shift n minus 1 by 2 only, right? So if you shift it, so this guy, same you can write like this only, like 2 3 4 5 6 7 8 4 5 6 7 8 and then 4. And now this where will be n? So you have to shift by 1, right? So what you have to do here is, if you will add here 1, right? So this is the minus 1 minus 2 minus 3 minus 4. So now it will be shifted to the right by 1, so it will be nothing but 3. So minus 3 minus 2 minus 1, and this is 0 now, right? Like this. So your 5 will be having now the marker. 5 will be having the marker. Now you can go for decimation. So decimation करेंगे तो क्या होगा? Decimation means 2n minus 1 by 2. Okay, I'm just going for decimation. So decimation means what? Decimation means you have to divide all these time instants by 2, right? So you have to only retain those integers, okay, which are multiple of 2, right? So you can forget about these, like, so this is not, this will be 0. Okay, now it is going to be 0 here, and this will be only the thing that 3. Okay, understood? So it will be having minus 1. So I'm just going to write those integers which are going to be retained. So you can say that 3 and then 5, then 7, because this is 1 2 3 4. So 7, and then this is 4 here. Okay. Understood? Now you have to make sure that this is n equal to 0. So ये minus 1 है, ये 1 है, ये 2 है, खत्म. Okay, you can draw it. 5 3 1 में 7, right? And then 2 में 4. This is the interpolated version of that, right? Okay, so I think this is enough, right? So how to introduce fractional delay, that I have told you. First you have to go for interpolation, right? Then you have to shift, then decimate. Okay. So this example I have taken from your embedder only. Now we will talk about commonly encountered discrete signals. Common discrete signals, guys. we have to speed up the classes as well, because so that we can finish this subject, one of the very important subject this month, and we can have the command on it, right? So yeah. Now, first is the unit step sequence. The discrete, we have to talk about discrete version of unit impulse, or you can say sample or sample delta n. We call it sample delta n. Units impulse you can say, or sample delta n, right? We have to discuss about unit step. We have to discuss about unit ramp, right? So impulse, impulse signal, right? Or you can say that sample delta n, okay, is defined as delta n is nothing but 1 when n does not equal to 0, and 0 for n, sorry, I should write it will be n 1 for n equal to 0 and does not equal to 0 के लिए ये 0 होगा. Okay, so in this case you will find that this 1 represent the height of the sample. Okay, in that case that was also the amplitude, infinite was the amplitude. Okay, in case of continuous, okay, if you recall, अगर आप continuous को recall करते हैं, so in case of continuous क्या था definition? Delta of t continuous impulse infinity at t equal to 0 and 0 for t does not equal to 0, and area under the impulse was 1, right? So this 1 was representing area in that case, but here this 1 represents the height of the sample. Fine, that is one point that you have to remember. Now if I talk about u of n, that is nothing but step sequence, step signal. I'm talking about discrete step, guys. How it is defined? It will be 1 for n greater than or equal to 0. In that case it was not defined at n. अगर आप continuous को recall करते हैं u of t, it is 1 for t all positive time, 0 for odd negative time, but it was not defined at, you see here, it was not defined at, you can say, t equal to 0, right? But now you can find out by some approximation. Gibbs phenomena told us u of 0 is going to be 1 by 2. Okay, so you can say that it is nothing but a heavy side. Okay, so we don't put here the open circle or something, just okay, like empty circle directly. Signal में थोड़ा सा math और signal थोड़ा different हो जाएगा, right? Sometimes we have to understand. So this will be 0 for n less than 0. मतलब all negative integers, the unit step is 0. For all positive along with the 0, you can say for all non-negative integers, right? Non-negative integers के लिए ऐसा दिखेगा, 0 में 1, 1 में 1, 1, 2, 3, 4, 5 and so on, right? So and here everything is gonna be 0. Yeah. So whether you can write in this format or you can show in this format, both are okay, right? So remember कहाँ से ये start होता है? 0 से start होगा. U of n always start from 0. 0 में 1 and all the values will be 1, right? And in this case, this is a continuous version of the step function, right? Continuous version of the step function. Okay. Now we will talk about ramp. What is this ramp? Discrete ramp I'm talking about. So R of n is nothing but n times un. N times un. And how do we write this as? From the same definition, it will be 0 for n less than 0. And it is going to be n for n greater than or equal to 0. Okay. That is one point that you have to remember. Now, discrete impulse is just a unit sample at n equal to 0, that I have told you, right? Discrete impulse is nothing but just an unit sample, right? Like this. N equal to 0 में 1. This is nothing but a unit sample. Okay. Unit sample. It is nothing but a sample value. Okay. Unit sample. The height of the sample is 1, right? And it is completely free of the kind of ambiguities associated with what? Analog impulse, right? So whatever ambiguity was there in case of continuous. It is so simple here, right? So the discrete unit step has also a well-defined unique value of u of 0. Somebody is asking, what is the value of u of 0 here? इस केस में u ऑफ 0 की वैल्यू क्या होगी? तो आप बोलोगे सर 1. क्यों? क्योंकि यहाँ पर कोई एम्बिग्यूटी नहीं है. देयर इज नथिंग लाइक एनी डिसकंटिन्यूटी, राइट? ठीक है, ये तो डिस्क्रीट है, डिस्क्रीट सीक्वेंस है, राइट? Okay, so always compare your continuous counterpart, analog counterpart, you can say, or continuous counterpart with the discrete counterpart, right? Okay, and since we have got the unit step, so we have also got the discrete ramp, जिसका स्लोप कितना है सर आप बता सकते हो, ठीक है? So I hope this makes sense to all, right? Now, so you can see here, just I'm gonna show you everything. डिस्क्रीट इम्पल्स, ये तीनों की पिक्चर आप देख सकते हैं, मैंने ड्रॉ करके भी दिखा दी है, बट ठीक है. ये दिस इज द स्टोरी हियर. द डिस्क्रीट इम्पल्स, द स्टेप, द रैम्प एंड द वेल डिफाइंड. ओके, दे आर ऑल वेल डिफाइंड गाइस. वेल वी हैव वेल डिफाइंड, राइट? यहाँ पर कोई डिसकंटिन्यूटी टाइप का कंसेप्ट नहीं डिस्कस करना है. n इक्वल टू 0 के लिए आप बता सकते हो स्टेट वैल्यू. व्हाट इज द वैल्यू हियर एट n इक्वल टू 0? दैट इज 1. ये n इक्वल टू 0 में क्या है? 1 है. यहाँ पर n इक्वल टू 0 में ये 0 है, राइट? ठीक है, दैट स्लोप. बट इन केस ऑफ रैम्प यू हैव टू टॉक अबाउट स्लोप, राइट? So properties of discrete impulse. Now we will discuss some of the important property of discrete impulse. You know that there is a product property, right? Product of, अगर आप दो सिग्नल का प्रोडक्ट करते हैं. Now we will talk about property of discrete impulse. ठीक है. So suppose we talk about product property, right? So if you take x of n and multiply with delta n minus k, right? Shifted version of the impulse, right? So what will be there? Same, the way you have discussed over there. Now you have to replace this n by k and delta n minus k, same. This is the product property. I think you might have seen the product property in case of continuous as well, right? So this is just an impulse with the strength delta k. अब यहाँ पर ये क्या है सर? This is nothing but the strength, okay, simple strength. Okay, like you can say that n equal to k, और इसका क्या है? Okay, and if you take the sum of it, right, the product property leads to the shifting property. अगर आप बात करते हो discrete counterpart की, तो you can sum, you can use the discrete sum, right? So discrete sum, n equal to okay, like you are running from, your summation is running from minus infinity to infinity x of n, right? X of n times delta of n minus k, right? So it is going to give you what? It will be giving you x of k only, provided this k should lie between these two integers, right? Minus infinity to infinity के बीच में होना चाहिए, ठीक है? Okay, so your impulse exists at n equal to k here, right? Your impulse exists at n equal to k. ठीक है, तो कुछ इंपॉर्टेंट पॉइंट्स हैं जो आपको समझना पड़ेगा बस, और कुछ भी नहीं है. And these are the property which are very similar to your analog or continuous counterpart, right? So there are some signal representation by impulse. So you can represent any signal with the help of impulse, right? Signal representation by impulse. So these are the chota thing, small things that will be used in case of communication system, right? To understand signal representation by impulse. So any discrete signal, what I said here, any discrete signal x of n may be expressed as the sum of shifted impulses whose strength is going to be x of k, right? And that strength is going to correspond to n equal to k, right? So any discrete time signal, you can say any discrete time signal can be expressed as the sum okay, sum over, right, sum over x of k delta shifted version of impulse function. This is nothing but a shifted version of impulse, shifted version of impulse having x of k as strength, right? और ये k का कहाँ से कहाँ रेंज होगा? K will range from minus infinity to infinity. So any discrete time, remember this statement, ठीक है, कि any discrete time signal x of n or sequence x of n may be expressed as the sum of shifted impulses. So this summation tells you sum, and this is shifted impulses, right? Okay, and जिसका strength x of k है, that correspond to the signal value x n equal to k, right? ठीक है. So आप you can think about now a discrete unit step, right? So following the same definition, इसको आप same definition follow करो ये वाली. So अगर मान लो तुम sorry, if you take the shifted impulse, right, delta n minus k, delta n minus k if you take, okay, and if you sum for positive value of k to n, you can say, right, k to n, sorry, k to infinity, you can say. Okay, so this will give you u of n. Okay, the weight, the strength of this guy is 1. Okay, so you can say that you're going to get like this. इसको आप अगर आप expand करते हो तो delta n plus delta n minus 1 plus delta n minus 2 plus and so on. So this is single impulse, right? Single sample, one sample. Second sample at 1, third second, okay, first samples, second, third, ऐसे, ठीक है? So any x of n, you can take x of n like, and you can just sum over k, right? So you will get unit step here. Okay. I believe this is fine for all, right? So this is one important point. And if you take delta of n and multiply with k and sum over, you know, k equal to 0 to infinity again, right? 0 to infinity. So this will give you r of n, which is nothing but a ramp. Okay, that is one of the important property again, right? So the signal u of n may be expressed as what? The sum shifted version of the impulses, right? Okay, understand? One more point will be there. One more point. You can also write this as the unit step sequence. The unit step sequence can be expressed as a cumulative sum of delta of n. Can be expressed as cumulative sum of x of n. ठीक है? Cumulative sum of delta of n, sorry, not x of n, right? So delta of n. What is the meaning of cumulative? Cumulative matlab you have to add from minus infinity to a current value, current time instant, right? So you can see that your delta of k is there. Now you're summing over k from minus infinity to n, and this gives you u of n. ये भी एक डेफिनेशन है, आप याद रखिए. दूसरी डेफिनेशन मैंने आपको बताई है कि u of n इक्वल टू समेशन k इक्वल टू 0 to infinity, right, delta n minus k. ये भी एक डेफिनेशन है. So these definitions you have to remember, right? कैसे definitions आ रही हैं? All idea I am covering along with that, okay? Like any discrete sequence can be expressed in terms of some shifted some of the shifted version of the impulses whose strength is gonna be x of k, right? ठीक है, चलो. So I think this is clear, and you can also express r of n as a running sum, okay, running sum of so अगर आप u of k को लेते हो और इसके ऊपर running sum लगाते हो, right, k equal to minus infinity to n, So that will give you ramp, discrete ramp, right? In case you can compare with the discrete like continuous counterpart or analog counterpart, okay. ठीक है, क्योंकि आपको पता है कि कंटिन्यूअस के केस में क्या होता है, अगर आपको आर ऑफ टी चाहिए तो दैट गिव्स यू फ्रॉम माइनस इन्फिनिटी यू ऑफ टाउ डी टाउ, ठीक है. In this case we say that minus infinity to t delta tau d tau, which gives us u of t. So in case of continuous there is a integration, and in case of discrete there is a summation, that's it. Okay, now the in case of continuous part we have discussed about pulse signals like rectangle, and triangle. Here also you can discuss rectangle and triangle, right? So I'm just going to show you directly, right? So I'm not gonna write again, ठीक है. तो आप डिस्क्रीट का भी देख सकते हैं, ठीक है. ओके, द सेम डेफिनेशन, द सिमिलर डेफिनेशन, ये पल्स, right, signals, but they are discrete in nature. Why discrete? I told you the property, right, ki in case of discrete there is a next and the previous concept, okay, but in case of other numbers like rational number, you say there is no okay. So if something is an integer, so there will be next and previous, that is gonna be discrete. Gap will be there between two integers. So discrete version of the rectangle pulse is nothing but rect n by 2n, okay, understood. और triangular का ये हो जाएगा. So this is nothing but always we say that okay, this is half width, this is the full width, you can say, and this is how we defined it, ठीक है. तो आप इसको नोट कर सकते हैं. Okay, how does this look like? I'm just going to show you, ठीक है. So suppose 5 samples are there, and so you can show it like this. Yeah, discrete, rect and triangular, right? So you have to just practice this by yourself, okay, how we draw this and all. तो ये उसी की तरह दिख रहा है ऐसा. Definition wise same, मतलब you can, but here everything is like it is discrete, not continuous, but situation is gonna be same. See here n equal to minus n, capital N में 0 है, ये भी 0 है, और height इसका width कितना है, 2n है, height is 1, इसका width 2n है, right, height is 1. Okay, so you can think about it, right? It's not tough. Yeah, I hope this makes sense to all. So let's say one question, let's take one question and try to solve this, okay. And अगर मान लो एक क्वेश्चन हम लेते हैं, उसको सॉल्व करते हैं, तो कैसे सॉल्व करेंगे? लेट मी suppose we have got a question like of this kind. Suppose we have got x of n, that is nothing but 2 raised to power n, right? ये exponential है, discrete exponential, okay. It will be growing always, right, as n increases, right? And by of n is given, that is nothing but delta n minus 3. Now you have got new signal zn. तो zn क्या हो जाएगा सर? मल्टीप्लीकेशन डेल्टा n xn and by n, right? So आप पुट कर दो तो 2 to the power n and delta n minus 3. What is this? Product property of the impulse, right? So in place of n there will be 2 to the power 3 delta n minus 3. So what is this? This is nothing but 8 delta n minus 3. Now you have to find the sum. तो आप इसका सम कर सकते हैं. तो इसका सम करेंगे तो कितना आएगा सर? I think you will get 8 only, right? तो अगर आप सम फाइंड करते हैं तो सम ओवर 8 times delta n minus 3, so that will give you 8 only, right? ठीक है. It's a very simple answer, very simple question, okay. Understood. So we will meet in the next session, guys. Again, today itself I will conduct one more session. So please keep following the Ambarder book, okay, and try solving the question, right? I will finish this chapter by today itself, right? Okay.